Okay, ma'am. Amma, kindly start recording.
Please start, Dr. Sadia.
Okay. Bismillahirrahmanirrahim. Rabbi zidni ilma. Stay positive, work hard, make it happen. Assalamu alaikum. My name is Dr. Sadia Rafiq, and today my topic of presentation is Descriptive Biostatistics. The learning outline includes the introduction of biostatistics, descriptive and inferential biostatistics, measures of center tendency, measures of variations, measures of position, and exploratory data analysis. Learning outcome. At the end of this presentation, my colleagues would be able to describe biostatistics, measures of center tendency, variation, and position, and techniques of exploratory data analysis to discover various aspects of data. Starting with the history. Descriptive statistics used in censuses taken by the Babylonians and Egyptians between 4500 and 3000 BC. In addition, the Roman Emperor Augustus conducted surveys on births and deaths of the citizens of the empire, as well as the number of livestock each owned and the crops each citizen harvested yearly. So, what is biostatistics? It is defined as the procedures and techniques used to collect, process, and analyze data to make inferences and to reach decisions in the face of uncertainty. Statistics. It refers to numerical facts obtained from the sample population. The fields of the statistics are included how data are presented, calculated, analyzed, and interpreted. When the data we use are biological, medical, or health related, the subject is called biostatistics. So basic terms in basic biostatistics includes population. It is a collection of individuals who share a common trait. Sample, a selection of individuals from population or set of possible observations. Data, the information that has been collected from an experiment, a survey, and a historical record. A variable is a characteristic or attribute that can assume different values. A statistics is a characteristic or measure obtained by using the data values from a sample, and the parameter is a characteristic or a measure obtained by using all the data values from a specific population. Types of data. One is qualitative data, which is also known as categorical data. It includes nominal data and ordinal data. And the second is quantitative data, which is also known as numerical data, includes discrete and continuous data. I'm not going in the detail because one of my respected colleague has already discussed this yesterday in very detail. Types of biostatistics. It has main two types, descriptive biostatistics and inferential biostatistics. Today, I will discuss with you the descriptive biostatistics, and in my next presentation, I will present you inferential biostatistics. So, what is descriptive statistics? It is a statistics which deals with the descriptive section of the dataset as well as have tendency to describe the dataset initially. The difference between the two types, descriptive are the numbers that are used to summarize and describe data. The word data refers to information that has been collected from an experiment, a survey, or historical record. Whereas in inferential statistics, the sample is a set of data taken from the population to represent the population. Probability distributions, hypothesis testing, correlation testing, and regression analysis all fall under the category of inferential statistics. So, the descriptive statistics consist of the collection, organization, summarization, and presentation of the data. Descriptive statistics summarize, describe, and characteristic the sample being studied. It determines if the sample is normally distributed, which is bell-shaped curve, because most statistical tests require the samples to have normal distribution. Determine if the sample can be compared to the larger population and displayed as tables, chart, percentages, frequency distributions, and reported as measures of center tendency. How to interpret descriptive statistics? It includes the measures of center tendency, measures of variations, measures of position, and exploratory data analysis. So the following measures which are used, we are call them measures of position, which includes the measures of central tendency or location measures. But then what is measures of spread? It also refers to as variability or dispersion measures, and then the measures of shape. Now we will discuss one by one everything. First come towards the measures of central tendency, which includes the mean, mode, median, and mid-range. Mean, the total of all the values divided by the size of the data set. It is the most commonly used statistics of position. It is easy to understand and calculate. It works well when the distribution is symmetric and there are no outliers. The mean of the sample is denoted by X bar and the mean of the population is denoted by mu. So as I've told you, it is the sum of the value divided by the total number of the value. The sample mean, as we discussed, it is presented by X bar, and it's the formula is like this: summation X of over the n. Sample mean, summation of the sum of the all the values and divided by the number of the values. The population mean, we have Greek letter mu. Same as the, so we will add up all the values and divide it by the total number. So the summation X is the sum of the data values. Small n is the number of data in sample and capital is the number of data items in the population. The mean is sensitive to extreme scores, outliers in the sample. As we have seen, this is an example. The data shows the number of patients in a sample of 6 hospitals who acquired an infection while hospitalized, find the mean. So we have this values we have while applying the formula summation X, we will add them all and we have total number 6 observation and divide it and we will get this answer, the mean. Now moving towards the median. The middle value, where exactly half of the data values are above it and half are below it. Less widely used, a useful statistic due to its robustness. It can reduce the effects of outliers, often used where the data is non-symmetrical. Ensure that values are ordered before calculation. With an even number of values, the median is the mean of the two middle values. So the median is the midpoint of the data presented by MD. The middle value is if like 50th centile, it means half of the data is below it and half is above it. It's the formula n plus 1 divided by 2 and showing in the normal Gaussian curve, all mean, mode, median, mode lie in the same place. And the median is not sensitive to extreme scores. Reason behind, we just array our data in ascending and descending order, then we take the middle of the thing. These are the example. As we can see, we have the 5 values. And if we have the data which is odd, the center one is always the median. When n is odd, median is a middle observation. And if we have the even, then median is we have to add the middle two values divided by 2, and then we have the observation. Same here, median calculation in or we have the center one, and in the even data, we just add up the two, and then we have this observation. Mode, the value that occurs the most often in a data set. It is rarely used as a central tendency measure. It is more useful to distinguish between unimodal and multimodal distribution when data has more than one peak. So we can say in this graph, in this values, the mode is 10 because it is the frequently repeating value. So depending upon the thing which I have talked about you in this, it is more useful to distinguish between unimodal and multimodal distribution. So these are different. Unimodal when we have one peak in the data set, bimodal, and then it is multimodal. Then the mid-range. The mid-range is defined as the sum of the lowest and highest values in the data set divided by 2. The symbol is MR, and this is formula. We can see lowest value plus highest value divided by 2. In this example, we have seen the lowest value is 1, the highest is 8. We'll add them up and divided by 2, and this is the mid-range. So moving towards a different graph sort of the distribution, it is called a normal distribution curve. Mean, median, mode lie in the same plane. And now this is show the skewed data. Skewed, this you can see that this is not normal distribution curve. It is skewed. The data is jumbled up towards the right side. So it is called right skewness or positive skewness. In this, the median is always in the middle of the data, whatever, if it is skewed up even, the mean is towards the left side and the mode is like here. And the left side skewness, which is also known as negative, you can see the this area, the number of data is jumbled up over here. The median is in center. The mean is here towards the tail, the way the data is decreasing, and the mode is this. And if we see the different shapes of by the histograms, it is the normal histogram, the symmetric value. So it is the positively skewed or right-sided skewed, in which you can see median, mean, and mode, and it is a negatively skewed or leftly skewed. Measures of variance. Next, moving towards it, it includes a minimum and maximum range and standard deviation. Descriptive statistic is also known as the measure of spread. The spread refers to how the data deviates from the position measure. It gives an indication of the amount of the variation in the process, an important indicator of the quality, and used to control process variability and improves quality. There are different statistics by which we can describe the spread of the data set, and range and standard deviation is one of them. Range is the difference between the highest and lowest value. The simplest measure of variability, denoted by R, good enough to many practical cases, doesn't make full use of available data. It can be misleading when the data is skewed or in the presence of outlier. Just one outlier will increase the range dramatically. As you can see, it is a data. It is the one outlier which is over here, and it increased the range this much. So the range is the minus the highest value from the lowest value. But in this example, you can say in the height, we have the height from 38 inches to 77 inches. And the range for calculation of the range, we will divide the maximum 77 to minus 38, and with this 39, we will get this. It is the range. Then the standard deviation, the average distance of the data point from their own mean. The low standard deviation indicates that data points are clustered around the mean. The large standard deviation indicates that they are widely scattered around the mean. For the sample, it is denoted by S, small s, and for standard deviation of the population, it is denoted by sigma, a Greek letter. So how it's a more robust measure of variability? It's the formula is given as S is equal to summation x minus x bar square divided by n minus 1 under root. S is standard deviation, is the mean, x is the value in the data set, and is the number of the data set. So moving towards the population. First, population variance and standard deviation. What is the variance? Variance is the average of the square of the distance each value is from the mean. The symbol of the population variance is sigma square. It's the formula summation x minus mu, because we are dealing with the population. So we have the mu. X is the individual value, mu is a population mean, and n is the population size. And the standard deviation is the square root of the variance. When we square root the variance, then it becomes the standard deviation. And after this sigma, we will do the square root. Then this will be the formula after the square root. You can see the difference. Just here, we have the added up the square root in variance, then it becomes a standard deviation. Now moving to the sample. First one of the population, now the sample variance and stabilization. The formula for the sample variance is small square, denoted by this. This is the formula. X bar is the sample mean and n is the sample size. And the standard deviation, as we know, the sample is denoted by s small s. So when we square root it, becomes the standard deviation of the sample, where the x is the individual value, x bar is the sample mean, and n is the sample size. Visual representation of standard deviation. 68% of the population and normal distributions lie within one standard deviation of the mean. You can see first standard deviation 68%, in the second two standard deviation 95%, and in three standard deviation 99.7% comes. The coefficient of variation, it is denoted by CVAR, is the standard deviation divided by the mean. The result is always expressed as percentage. Again, the formulas are different from the samples and for the population, and the coefficient of variation. The samples is standard deviation divided by the sample mean multiplied by 100, and the formula for population, sigma divided by mu multiplied by 100. Now moving towards the measures of shape. Data can be plotted into a histogram to have a general idea of its shape or distribution. The shape can reveal a lot of information about the data. data will always follow some distribution. It may be symmetrical or non-symmetrical. This is the symmetrical shape. You can see a bell shape, mirror image of each other. In a symmetrical system, the two sides of distribution are a mirror image of each other. Example of symmetrical distribution include uniform, normal, camelback, bow tie shaped. The shape helps identify which descriptive statistics is more appropriate to use in a given situation. If the data is symmetrical, then we may use the mean or median to measure the central tendency as they are almost equal. If the data is skewed, then the median will be the more appropriate to measure the central tendency. Two common statistics that measure the shape of the data are skewness and kurtosis. Describe whether the data is distributed symmetrically around the mean. The skewness value of 0 indicates perfect symmetry. The negative value implies left skewed data, and the positive value implies right skewed data. Kurtosis measures the degree of flatness or peakness of the shape. When the data values are clustered around the middle, then the distribution is more peaked. A greater kurtosis value. As you can see here, this sort of graph is called leptokurtic. Because the distribution is good, it has more peak. When the data values are spread around more evenly, then the distribution is more flattened. You can see like this, platykurtic. It's flattened, it's broader. The smaller kurtosis value. And so we have different names for these all curves. Platykurtosis, which is flattened, mesokurtic, and the leptokurtic. Skewness and kurtosis statistics can be evaluated visually via histogram. We can also calculate it by hand. This is generally unnecessary with modern statistical software such as Minitab. Now, moving towards the measures of position. A z-score or a standard score, percentiles, quarters and deciles, and outliers. Z-score or standard score. A z-score or standard score for a value is obtained by subtracting the mean from the value and dividing the result by the standard deviation. The symbol for the standard score is Z. The formula is Z value minus mean divided by standard deviations. For example, we are saying this is for the sample and this is for the population. In sample, Z values is X minus X bar over the standard deviation, and the population X minus mu divided by sigma. The z-score represents the number of standard deviations that a data fall below or above the mean. As we see in the normal distribution, the empirical rule for any normal distributed data, 68% of the data will fall within first one standard deviation of the mean, 95% of data fall two standard deviation of the mean, and 99.7% data fall within three standard deviation of the mean. You can see this, the mean is the values, normal standard of one standard deviation, 2 and 3, and it is the data falls in this, and we divide into right and left, positive and negative, this data according to this. A common practice to convert any normal distribution to the standardized form and then use the standardized normal table to find probabilities. The standard normal distribution or Z distribution is a way to standardize the normal distribution. It always has a mean of 0 and a standard deviation of 1. So by the normal distribution, any normal distribution converted to standardized by this formula, I have discussed it with you. The value is divided is minus by the mean divided by the standard deviation. X is the data point in the question. Z score is a measure of the number of standard deviations or data point from the mean. This is Z. Percentiles. Percentiles divide the data set into 100 equal groups. Percentile is always made in 100 from 100. Then quartiles and deciles. Quartiles divide the distribution to 4 groups. separated by Q1, Q2, and Q3. You can see that it is the smallest data value, Q1, Q2, Q3, Q2 is called a median, and it is the largest value. Then the outliers. Then outlier is an extremely high or an extremely low data value when compared with the rest of the data values. An outlier can strongly affect the mean and standard deviation of the variable. I describe it further. This thing is a box plot where it's being drawn, and these are the outliers. So the data point that is significant or smaller than other data points are set. It is useful when analyzing data to identify outliers. They may affect the calculation of descriptive statistics. Outliers can occur in any data set and in any distribution. Outlier. The easiest way to detect them is by graphing the data or using graphical methods such as histograms, box plots, and normal probability plots. In this histogram, you can see this outlier. In the box plot, you can see this an outlier. Outlier may indicate an experimental error or incorrect recording of the data, or it may occur by chance. It is normal to have high or low data points. You need to decide whether to exclude them before carrying out your analysis. An outlier should be excluded if it is due to measurement or human error. So this is an example about time taken to process sample of application. You can see this is the data and this is one outlier. It is clear that one data point is far distant from the rest of the value. This point is an outlier. Now moving towards the exploratory data analysis. EDA. EDA was first developed by John Tukes and was represented in his book in 1977. The purpose of EDA is to examine data, its center and spread. In exploratory data analysis, data can be organized using a stem and leaf plot. The measure of center tendency used is median. The measure of variation which is used is interquartile range. And data is presented graphically using a box plot, which is also known as box and whisker plot. There are 5 number summaries and box plot. Box plot can be used to graphically data set. These plots involve 5 specific values. Without these values, we won't be able to draw a box plot. What are those? Number 1 is the lowest value of the data set, which is the minimum one. Then the Q1, then the Q2, which is median, then Q3, and the highest value in the data set. And then moving towards how to construct it. Box plot is a graph of data set by drawing a horizontal line from minimum data to Q1. As we can say, this is Q1, median, Q2 and Q3. We will draw from minimum data set to Q1, one horizontal line, and drawing a horizontal line from Q3 to maximum data. From maximum data is here, and we will draw a line from maximum to Q3. Then we will draw this box, drawing a box whose vertical sides pass through Q1 and Q3, and a vertical line the side passing to a median. So it is the lower quartile, upper quartile, it's the median, this is the box, and this is the whisker. That is why it is called box and whisker, or box plot. Here I end my presentation regarding descriptive statistics. These are my references. And now moving towards the multiple choice questions. Number 1, the summary statistics which measure the middle or center of the data are called logarithm, measures of center tendency, measures of proportions.
Beta.
B.
Yes, it's the measure of center tendency. The average of all observation in a set of data is known as
Mean.
Mean.
Median.
Mean.
Mean.
mean. This one is easy one. Statistically, the spread or scatterness of observation in a data is called discriminant.
Dispersion. Dispersion.
Standard.
No, it's not standard deviation, it's dispersion. We see how much the data is dispersed. The mean of the squared deviation of some observation from the arithmetic.
Standard deviation.
No.
Variation.
Very carefully, I've said the mean of the square deviation. So it's the variation. The positive square root of the mean of the square deviation of some observation from the arithmetic mean is called
Standard deviation.
Standard deviation.
standard deviation. The difference between when we have the square, then it is the our variation, and when we take the square root, then it's the standard deviation. Sum of the deviations of a variable from its mean is always 0, 1, 2, and
0.
0.
One.
Yes, mean is right. No, it's 0. The sum of the deviation of variable always from the mean is 0. Next, if for a distribution, the difference of the first quartile and median is greater than the difference of median and third quartile, then the distribution is classified as absolute or
Negatively skewed.
C. Negatively skewed.
C.
no. Read it
Negatively.
again. I have said that the distribution, the difference of first quartile and median Q1 and Q2 is greater, is larger than the difference in the median and third. It means it is larger, so it is positively skewed. The right answer is positively skewed. In statistical procedure, the skewness is used to measure amount of variance, amount of upper tail values, amount of dispersion, and direction of dispersion.
D. D.
No,
Direction.
no, it is used to measure the
C.
amount of dispersion.
C.
How much is this? It is positively skewed or negatively because the data will be jumbled around it will be collected towards the mean. So the amount of dispersion. In kurtosis, the frequency curve which looks more peaked than normal curve or bell-shaped distribution is called as
Leptokurtic.
yes, it's called leptokurtic. The frequency distribution is considered as negatively skewed if all the values of distribution moves to lower tail, middle tail, variance tail, or upper tail.
Lower tail.
Yes,
Lower tail.
lower tail.
A.
Lower tail, yes, it's A. This is the key, and thank you so much.
Thank you very much, Dr. Sadia. As I have told you in the beginning that this is a wonderful presentation, excellent presentation in other terms. However, there is always a room for improvement and we want to make the things even better. So the MCQ part, I always look for the scenario-based questions for the clarity, especially the question number 6. If you go to the question number 6, you can see that it is not the right question that should be asked as MCQ. All the MCQs should be scenario based, and especially when we are talking about centered tendency and dispersion, we have to show that how the different values they are present in the mean. Similarly, if you go to the please question number 6, then there is another question that was absolutely wrong. I want to have little clarity about it.
Okay, ma'am, which one?
Okay, sum of the deviations of a variable from the mean is always. So it is not always and always that sum of the deviations of a variable. For example, if you have a scenario where there is a variable, first you have to calculate the deviation. The deviation is from the mean. So
Yes.
from the mean, when you have all the sum of the deviations, only it is the characteristic of a normal distribution curve that the sum of the deviations of a variable should be 0. However, we have other distributions like we have Poisson distribution, we have skewed distributions, etc. Here, the deviations would not come to be 0. So
I
you
will
first have to give us a scenario that there is a normal distribution, and you can even show clinical case that there is a person who is having, there are 10 people who are presenting with certain disease, and they have the value of their hemoglobin like this, and this is the deviation, and they are following the normal distribution curve, and then you can put this question. Similarly, I hope you got my point.
yes, ma'am, I will correct you.
Right. So this is not for this. Similarly, you have shown another MCQ for skew distribution. Would you please go to that?
This one?
No. So in that MCQ, you have used the word skew distribution. Not this one. Please go to the previous one, 8th number. Right. In statistical procedures, the skewness is used to measure the right. Again, this is again a very confusing MCQ because no scenario has been given. First, you have to develop a scenario for the skewness, and then the skewness would help not only in determining the amount of dispersion, but also the direction of dispersion. Even we can know that where the dispersion is occurring more and where the dispersion is occurring less. So it is also giving us the idea about the direction of the dispersion.
Okay, ma'am.
Similarly, yeah, Dr. Sadia, would you want to please add something into it?
Yes, ma'am. I'm saying you are talking about we have some sort of complicated question and along with scenarios. Inshallah, I correct them.
Right. Similarly, the skewness also helps us to find out the amount of variation, how our data is having the variance in it. Similarly, you have done a good presentation. I was looking for a very important term, that is coefficient of variance. How you would define the coefficient of variance and what is the importance of coefficient of variance? Anybody from the class? Would you please want to add into it?
Um,
Standard deviation divided by number of values is
uh,
coefficient of variation.
It is no, it is not coefficient of variation. If you are dividing the standard deviation with under root n, what you are looking for?
Ma'am, the coefficient of variation is used when if we have two samples and they have the same unit, then they can be compared directly. But if we have two samples and the measure of unit is different, then we basically use coefficient of variance.
Right. When we have the same units, we would not use the word coefficient of variation. Please note it. When we have different units and we want to compare those variables having different units, then we use coefficient of variation. We often have this saying in research that oranges can't be compared with the apples. Yes,
Yes, ma'am.
oranges can be compared with the apples. And this is the coefficient of variation that helps us in identifying what are the similarities in the data when the different units are being used, right? For example, if there is some cricket match and one person has to be declared as a man of the match, then who should be? Either the bowler or the batsman. Now, the batsman has a different traits. Similarly, we sometimes have the data that has a very different units, and it has to be compared with other variable that has different units. So we use the coefficient of variation to find